So the division, and we are going to use the long division for this. By long division, do you remember the sign that we normally use for the division? The divisor, and this is the divisor, the blue term. This divisor will be outside over here, x minus 1. That's a divisor. And the dividend, the expression, the trinomial here, this expression will be inside this sign x squared plus a 2x and then a minus 3. Now, the easier way to figure out what should we do to divide, what should be the quotient here, the term that will come as a result on the top here will become a quotient. So how will I find what to multiply it with? Giving you an example that you have done all the time throughout your life, the long division, like we have given an example, 48 divided by 6, remember? And we can simply bring in a number that divides the dividend completely. 6 eighths are 48, and what's the remainder? 0. What do we do actually here? We subtract the numbers, and then we find the remainder. It's the same process, but now instead of numbers, we're going to use the variables. So we need to figure out something similar over there. We did figure out that 8 is a number that divides the 48 completely in 6 divisors, right? Here, we don't have a number. We do have a variable with an exponent, and then there is a variable outside also. So to decide what should be the quotient here, I will suggest you to think about the first terms only. The first term here is an x squared. Just think about that. And then divide this by the first term in a standard form of the divisor. What should this give you? It will give you an x, right? It will give you an x exactly, because you will subtract the exponents, and 2 minus 1, you can simplify it also, 2 minus 1, and that's giving you an x. So this is the quotient. Now this should just be a thought process. I'm not expecting that you will every single time write it. You can, but you don't need to. It's quite a simple thing. So keep it in mind and figure out this number, the x. That's what you will now be multiplying with the whole binomial, not just with one thing. So I'm going to put that over here, x minus 1. And this work should go to your scratch paper. Maybe you can put a line on the side, or you can use a scratch paper for this. X minus 1 will now be multiplied with an x that you just figured out. The benefit. When you will multiply, you must multiply and distribute the x to both of these terms. And that will give you, as a first multiplication, x squared, and then a minus x. Right? You first multiplied the x with an x, and that gave you the x squared. And then you multiplied the x with a 1, and that gave you the x distributed. Now this is a term, this is the expression that you will bring down over here, matching the exponents. X squared will be below the x squared over there, and the x, this is going to be below the x term. So we will match definitely the variables. What was the sign here for the x? This sign is a negative sign. So I will also bring in over here a negative sign. Did you get the steps? So first we did the thought process. What should I multiply the first term with to get the first term, and that x I have written over here. So I got the first term of the quotient. Got it? And now when we did the multiplication in the scratch work, we got this x squared minus x. Now like we did the subtraction here also, we're going to do the subtraction, and that will mean, here we have a plus, that will mean you're going to change the signs. This plus will be a minus now, and because I'm changing the sign, I will change every single sign. The negative will become positive. Now these are the signs that I will be using to do the operations. Subtraction in polynomials mean you're changing the signs, and then with the new sign, you're operating it for addition or subtraction, whatever the sign suggests. right? X square minus x square. That will be a 0, so we can forget about that. That's gone. Here, 2x plus x. I'm no more considering this minus now because I have changed the sign already. So 2x plus x, what will that give me? 3x. And then I will bring this expression down and that will become minus 3. Now think about the same thing again. What are the first terms? Take these first terms and think about what can you multiply that will give you a 3x. What should I multiply this x with to get a 3x? 3, exactly. You see, that's the thought process simply. So what will I do? I will again multiply the x minus 1 with the 3 and both distributed. This will be distributed over both, and that's going to give me, what will it give me? Exactly, 3x minus 3. So let's put it over here, 3x minus 3. Then that means I will take that 3, which has given me the first expression exactly matching. I will take that 3 and put it over here. Now with the plus sign, plus 3. So then I will do the multiplication and I got exactly matching result. So when I'm going to change the signs, this will definitely make it 3x minus 3x is 0. 3 minus 3 is 0. So what's the remainder? 0 is the remainder. And that means for us, we can claim that if I will divide this whole trinomial with x minus 1, the result is going to be x plus 3, right? That's the quotient. That's my result. This is the quotient. Come on. Okay. And this means another thing. That's my result. It also means this fact that if I will multiply x minus 1 with the quotient x plus 3, that is also definitely equal to x squared plus 2x minus 3. So we did the long division to find the quotient, and then definitely like over here, when we say 6 times 8 is a 48, it's true in these cases also that the trinomial that we divided, the dividend, it will definitely be equal to the product of these two terms, right? These two expressions. So remember, we call these 6 and 8 factors of 48, right? 6 and 8 are both the factors of 48. Similarly, these two blue highlighted expressions are also the factors of the trinomial. That will lead us toward the factoring of polynomial also, which is actually a division, but we will learn some techniques on that also. Got it? Okay.